Hello guys, and welcome to another Super Circuit Maker video where I have built a really cool thing. It's an analog 7 segment display decoder, and what that means is that I can take an input signal, which is analog since it can be 0 to 15, which translates to 0 to 255. And display the exact decimal number on these three displays. Personally, I think that is really cool, because that means that you can actually take some, you can measure anything outside that translates to a redstone signal, and you can show exactly how much what you're measuring is. You could also, as I've done here, translate it to percentage instead. It's exactly the same thing but with different constants, so it's really not a big thing. I will come back to that small build a little later. But as you can see here, it's really compact, and it's basically impossible to follow this build unless you already know what it is or have the plans. The blueprints. So of course the blueprints are in the video description. I will paste them in the end of this video. But first let's just demonstrate how it looks, and then I will demonstrate on a flat surface how it works and really the mechanics of it. Before I do this, I just want to say that if you want to understand this build completely, then you should watch the two previous videos for Super Circuit Maker that I have already released. They are in the playlist. You can find the link in the description if you're not already in it. So watch those two first, because I will use those two to make this. So now here's the input. This is the key input, and all of these have the input in the lower left corner. So if you break those free, remember the input is down here and the output to the next part is on the lower right side. That's on both. The final one has no output since, well, it's the lowest number. Here I have a constant. This means that I can change it for this video, 87 or 197. Etc. So it's this is truly analog. 200, perfect. Or I can just disconnect it. Then it says 0 everywhere because we have no input, as you can see here. And let me remove this one, it will be easier. But over here we have the redstone. So this one here is maximum power. This is power level 15, and as you know, that translates to 255 here, and that's also what we get here. If I turn that down, it will drop with 17 down to 238, and so on. So if I drop a few more, then we'll have 204 and then 187. Yep, it takes a second for all the calculations to be done, and all the way down to 0, as I said. So, and right, and I can just mention this, that if you want to translate it to 100 percentage as a maximum, as you can see here, 255, and if I drop this, then we have 204, which is over here. That means 80%, roughly. I haven't really double checked if the decimal is perfect, but it's basically pretty good. So 73%, and bad weather, and all the way down to 0%. The only difference here is that I try to make something useful. So when we are full, we have two outputs here. one output. The first one is if we are below 100%, then this one will be turned on. And if we reach 100%, the redstone output is off. If you want the opposite, only do this, then we'll have redstone output if we have 100%, and no output if we have less than 100%. So this is one application, the other one is another. Now let me show you how it works and how I built it. Just remember that this build and that build, they are equal except for the constants in the calculations, which I will go through right now. Perhaps it's not easy to see, but this is the exact same build as down there. Here's the constant. It is set to 243 and you can see the 243 here. So the first thing we do, we have it in 3 parts. We have it in one part here, second and third. And those 3 parts are combined into one board here for the first part. Second part is like 4, it's 3 floors high plus that redstone torch that makes it 4. And this is the third part. Each one of these controls one digit and they have to be in this order. So this block, this circuit, will control the hundreds. This part, the second, will control the 10th. And the final one, of course, the leftover, the less than 10. As I said, you really need to understand the previous builds, but I will still mention them quickly. If you remember this build, all the way up here, right, that was an in-between build, where we have an input signal over here, 255. This was the binary output, but it's still the same principle. So here I'm checking for 128. If we have 128 in this one, in the number, which we do of course, then we get a 1 here. And we remove that, then we have 127 left. And this one checks for 64. So if we have 64, it will output and then so on. So that was the binary output. Then if we take a look over here, this one is actually the first number, but we can stay. Where are we? Here. So this is, all right, I put them here. So the first part, note that we have 2 circuits for the hundreds. It's this one and this one. And we have, these are the outputs. This part is this. We take the input signal either from bottom or left. All the ones look the same in case I wanted to be flexible, but you should actually manage with only the bottom one. Input signal, check for 200. If we have 200, output 1. If not, well, then we'll just get the same signal over to the next part, which checks for 100. If we have 100, then output 1. Then let's go back here. So this part checks for 200. Since we have 243, this circuit will output 1. This 1 is the input to this circuit, and that one comes from the first of the 2 videos I referred to. This one. Yeah, right. So all these numbers are different colors to the 7-segment display. And it looks something like this. This is a 0. That means we input anything, but only these colors will be output. And if we go into this mode, then you can see it's only the color output, no redstone output. If 1, then only these two colors are sent through, and so on. This is a 2, this is 3, this is 4. So now let's go back into our circuit. So if we have a 200, this one will be 1, and that input in here will output a number 2. If we don't have 200, then let's check for 100. If we have 100, we'll output 1 here, and then this circuit will output a 1. If we have neither of those two, let's see. No, not like that. Now a 203. So this one is true, and we'll output a number 2, like this, 1, 1, 0, 1, 1, and so on. Then we'll get a 2. If we change this to less than 100, then we have 83, we have still 83, and still 83. That means that this is 0, and this is 0. Not 2, not 1, so we have to have a 0. The 0 is output by using OR gates. This connection it works like an OR gate. So we OR this signal to this signal up here. So the white goes in, up here, and out. And white also comes from this part. So here we have basically orange or magenta. If any one of those is 1, it can only be 1. But if we have 1 here, then this will be turned off. But since we have a 0 here and a 0 here, this will be turned on and send out 255 here. And that means we will turn on the 0. And the 0, the code for 0 is sent to this 7-segment display, where you can see the result. I covered the display already. So what's left? Then we have still 83 here. And now this is a slightly large part, because since we're not checking for hundreds, we need to check for every step of 10. And then we can go up here and see. Here we have the 90, 80, and so on. Still exactly the same. Everything looks the same so far, except for this constant. Check for 90, and next one checks for 80, and so on and so on and so on, and the last one checks for 10. So let's go back here. Here we check for 90. Do we have 90 in 43? Oh, 240. Oh yeah, I checked the wrong one. 83, whatever. I have two setups. I always work in doubles, since I have, if they crash, I want to have a backup. So we still have 83. Do we have 90? No. So this is 0. Do we have 80? Yes, this will be 1. Then we'll output an 8. So this is 9, 8, 7, 6, 5, and so on. And here it's exactly the same. And don't forget that we output a 1 here. That means that we'll get a 1 up here. So either one of these signals, if we have any digit, if we have any tenth, then white is turned on. This one will be turned off. This is a 0. So if we have any digit, any tenth, then we should not have a 0. And that means that the 80 we have here will produce a number 8, and we remove 80 from it. So we are only left with 3 here. And that 3 is sent through because in 3 we have not 70, not 60, and nothing. So that 3 is sent to the final part where we check for 9, no, 8, no, etc. until we reach 3 here. This is 3, that means we have 1 here and 0 here. The leftover is 0. And of course they work in the same way. We have the output 9 and 8, etc. and this is the 1. We don't need to oh, not redstone. We don't need to continue the output as we do here and remove, because this is the final part. This is either 1 or 0. It can't be anything else. So if it's a 1, then we'll output 1, and if not, well, then it's a 0. So the constant here is 1. And let me get back here. This is the 1. We have no output from there, and this works exactly as the previous one. So that means that we can check the analog input, 255 or 0 or anything in between. Check it for hundreds first, remove the 100 if we have it, then check for the 10th, and then the leftover digit. So it's quite simple, but it's quite a lot of steps. There are lots of redstone circuits on circuits, and when we translate that to this build, well, it's fun to build, but I guess it's quite impossible to follow. So it's only one thing left to do, and that is to give you the blueprints so you can do this all by yourself. So let's start with this one. Please tell me, I will leave those. Sometimes I remove these just, you know, I should do this. Just to be sure that nothing strange happens when they are on the limit or on the edge. So please remember to connect them together. You need that output to go to this input and so on. So this is the first, and we'll do export. This is for the hundreds. And then the second, the links again are in the description. No need to write these down. I'll do that. This is the second that checks for the 10th. Export. Perfect. Now we have 2. And we have the third one over here. And we'll export that for you as well. And then the final, well, I will give you the display as well. I might as well. That's the fourth one, is the display. So now you can do this. And if you want to change these, now this is quite important. So 1, 2, 3, and 4. I need to keep track of these. If you want to change these, well, then you simply do like this. Oh, that's what's happened when you copy it instead of using the blueprint. So let's use the blueprint instead. Let me use the second one. That works better. Now, if you want to change this, then you simply take this one, redstone circuit, put it over here, and you'll change this output constant to a percentage instead. Or if you want to have other, I don't know why, but you could have other numbers as well. So since I'm checking for 90, 80 and so on because I want 10 outputs, if you change it to do percentage instead, then you need to be, I have a table in the video description, but for example, 230 is 90%. So if I want to check for 90, then I'll need to check this for, change this to 230. And if I want to check for 80%, then it's 204. So it's not very hard, but you need to remove this one. You change this output to whatever you want to do. You copy it back, place it back here. Remember to turn these outputs on. And you do this with this, and these outer ones, and these outer ones. That means everything on this side needs to be changed if you want to do percentage instead of the raw number, if you want to. And if you don't manage, then just tell me and I'll get you some links instead. It's not too hard. So I think that pretty much covers it. So this is an analog 7-segment display decoder, and it's a triple decoder but spread out on 3 blocks. This is really fun to build, and this can actually be quite useful in certain builds. But mostly, I just hope you enjoyed watching this, because I think it's really interesting and fun to do this. I mean, when you look at the product, awesome. All right, thanks for watching, and I'll see you in the next one. Take care. Bye-bye.